All right, there's part two of our discussion on cranes. So add stiffeners in a runway beam. So if you have a crane bracket, you're going to want to add stiffeners at the end. Um, it's again good practice if you have a step column, same thing. If you have uh, step columns, then you want to line your stiffeners up with the flanges on the column. Don't connect the beams; you'll get cracking there at the bolts. You want to allow these things to rotate. What you don't see is the bolts right here and here. We talked about that in our previous video. You got various methods of runway beam design. A W is the easiest, a W in the channel, and then the rest of these three configurations are if you're really in trouble. So if you got larger cranes, you can do that. This channel and W section is efficient, but unless you're a fabricator of great talent, it's not practical because this is a little bit stronger because of the flange on the top of the W section. So here you'd just use plates, right? So this is welded in the shop. So it's just not something that's practical. Certainly not something popular. Over here on the far right, when you have a large, say, category, E or F crane, you start trussing this thing out. You start putting vertical web members in there to kind of get that deflection down. And then here, horizontal issues you got. Now here it says continuous plate. What that usually is used for is if you have a cab operated crane, you got to provide a walkway for them. So you might as well use that continuous plate as the walkway and as part of the structural design. Here on the opposite side of the cab, instead of using that continuous plate, you would just truss it out, right? So it's just an efficiency thing. When you're designing any of these cases, remember your lateral load is at the top of the rail. So the rail size is something you need to obtain from the crane manufacturer before you start this whole design process. Um, so, you're going to have to deal with that rotational uh, load there. The other thing you've got to look for is web crippling on the beam. So if you've got a load on the rail, this is how to determine the the area of the web that's being checked for the wheel. You usually don't have problems with this unless you have heavy cranes on short spans. So the short span allows you to use a smaller beam with a smaller web, and that's where you run into issues. If you have a case where the runway beam on the right is a bigger span than the one on the left, you would just step the column like this. Okay, you can in theory kind of change this slope of that flange, but it's just it's more welding, it's more opportunity for things to go wrong. You're just better off to just step the column. It's a lot cleaner detail. You got to select compatible members when using a built-up member. So here, you can see right here, there's like a 3/4 inch from the fillet to the flange, but you can certainly check that. But if you look at the back of AISC Design Guide number 7, they have a bunch of combinations that they've already checked and they say that works. Um, Interestingly enough, this 3/4 inch rule, I have found some combinations where that doesn't exactly fit up or meet that criteria. But I contacted AISC about it, and they said, we've been using these for years, and that works just fine. So you might see some combinations that don't fit this rule, but you know you do need to make sure that they can get in there and weld that. Specify the runway beam welds when using a built-up member. So you have to design that weld. You have to design it for simultaneous vertical bending and horizontal loads. So you got to pay attention to how you're designing those welds. It's customary that the person supplying the runway beam supply the crane step. Now, here's a couple examples of that. Notice that both of these options or all of these options are bolted. That's just it's because in the shipping process, if you just have this little metal piece sticking up, it tends to get bent. Or potential to get bent is high. It just ships better as a separate section. But you do need to know the elevation of the buffer. So here it says crane bumper, but the proper term is buffer. OSHA says that this thing has to decrease or decelerate the crane at a certain rate. Well, it has parameters that the crane manufacturer can use. So make sure they give that to you. Otherwise, you can't figure out what that force is. Okay. Um, the main reason why uh, the person supplying their stop, the crane runway replies does the stop because you can specify on the plan, say, hey, the crane manufacturer has to supply the stop, and you might get away with it. But because the crane manufacturer is not getting paid to do the runway, they don't want to add that extra thing in. So um, you could potentially get away with it on the note, and if someone's smart enough, they'll pick that up. But it's been my experience that you'll get an RFI at the end saying, "Give us that information." Hook bolts or clamps must be used to fasten the rails. You cannot weld rail. Rail is not weldable, so it's a brittle weld. So here's all the different options that you have. This is just bolting it down, bolting it down. This threaded stud, nobody does. It's a waste of a view. No, nobody does that. And then of course you can just weld it directly down with proprietary systems. So this is fairly common nowadays. So, with that said, if you do the bolt down option, which nobody does because it's a coordination nightmare, you do have to pay attention to where those bolts go. Some companies use 2-inch square bar as a rail. Categories A through C it's fairly common nowadays, but you know there's debate there on whether it's the right thing to do or not. So, but not our problem. The 2-inch bar must be welded down. There is no bracket or anything, so that's not an issue. But because the bar is so heavy, it does require preheat. And in Michigan, where we are, try to preheat that in February. It's just not real practical if it's outside, so they usually have to enclose the building first. 2-inch bar must not be spliced at the runway beam splice location. So you don't want to. We don't recommend that the bar be shop welded. Number one, it doesn't give that nice straight line. Number two, you really don't want to have the bar, have this half-inch gap or whatever you're going to put between the runway beams. You want a section of rail that goes over the top so that as that thing flexes, you're just not going over the top of that splice. The 2-inch bar splice locations do have, it's customary to kind of do this little PJP and then they weld it flush so that the steel wheel that runs over the splice doesn't thump. And it's very common to do it that way. And if you see that weld cracks, hey, that's okay. It's common. Again, it's just more for making that, you know, ride of that steel wheel on that bar smooth. Brace at the runway elevation. So here's an elevation of an exterior wall. You can see the girts, but we have that special brace, at there. But this would be the runway elevation. Um, and the idea here is that as that crane stops, this X bracing is very stiff, and we're going to stop any kind of movement in that longitudinal direction of that crane. Braces should not attach to the runway beams. Obviously, as that load goes over, that runway beam deflects. If you do brace to that, you're going to put load in the braces. You'd have to design that for fatigue. Just not optimal. So if you do something like this, just separate the strut from the runway.